This video will be about combining like terms. Like terms are terms that have the same variables and same variables raised to the same powers. Like terms, an example of that, 5x and 3x, 10x squared minus 11x squared, negative 29x squared y, 7x squared y, and even numbers without variables at all are considered like terms, for example, 8 and 100. So notice in each case, we have the same variables and same exponents on our variables. So if any of that changes, then they are not like terms. So 5x and 3 would not be alike. One has x, the other one doesn't. 10x squared, negative 11x, one has a power of 2, the other one doesn't. And even if both of them have x squared, x and y, one of them has a power of 2, the other one does not. On the x, in that last example, negative 29x squared y and 7xy, they are not like terms. So why is it important to have like terms or recognize that we have unlike terms? Well, like terms are terms that you can add and subtract from each other with no problem. So if they're unlike, then they are not possible to be able to be combined through addition or subtraction. So here on this right column, we have a few examples, very similar examples, but certain things have changed, so that prevents us from being able to combine them. So on the first one, 5x plus 3x, that would just be 8x. 5x plus 3 would already be in lowest terms. I cannot add those together. 5x plus 3y, one has x, the other one has y, cannot add them together. Here, 5x squared plus 3x squared, that would be 8x squared. Notice the power stays the same, so it's 8x squared. All you do is add the numbers in front of your variables. And then we have 5x squared plus 3x. Since one has a power of 2, the other one doesn't, we cannot add them together. It's already in lowest terms. So let's look at a few examples of combining like terms, simplifying expressions. Here we have 3x plus 5y minus 2x plus 9y minus 7. So we'll combine the like terms. Anything that's not like, you just go ahead and bring it down into the next line. So 3x minus 2x is 1x. 5y plus 9y is 14y. And then this negative 7 couldn't combine with anything over here, so you just bring it down. So we have 1x plus 14y minus 7. Now, to represent your answer in the most simplified way, you recognize that 1x and x are the same thing. In your final answer, you will never see 1x or 1y or 1a. You would just see that variable, and they assume you know there's a 1 in front. So our final answer is going to be x plus 14y minus 7. Next one, we have 5 minus 2 times the quantity of 3x plus 8. So we distribute not just 2, but negative 2 into the parentheses so we can have access to these terms. Negative 2 times 3x is negative 6x. Negative 2 times 8 is negative 16. Combine your like terms. 5 minus 16 is negative 11. So you can write this answer as negative 16 minus 11 or negative 11 minus 16. It doesn't matter which way or which order you write them, as long as your terms have the same symbol in front of them. If it's positive, make sure it stays positive. If it's negative, make sure it stays negative. So over here, if I were to rewrite this expression from the previous problem, let's say if I wanted this 7 to be in the front, that's fine. Just make sure it stays negative 7. X stays positive and 14y stays positive. Okay, a few more examples. Here we have negative 4x minus 6y. The 4x minus 6y is inside the parentheses, negative sitting out front, minus the quantity of 3x plus 5y minus 2x. So whenever there's something sitting out in front of parentheses, whether it was a 2 in the first problem or just a negative, it has to be distributed. So the negative goes to the 4x, which turns into negative 4x. Negative times negative 6y will turn into positive 6y. Negative times 3x is negative 3x. Negative times 5y is negative 5y. Now that all of our parentheses have been removed, we combine our like terms. Negative 4x, negative 3x is negative 7x. And we have a negative 2x back here, which would be negative 9x. 6y minus 5y is 1y, which will give me a final answer of negative x plus y. Next one, 1/4 times the quantity of 4k plus 2 minus 1/2 times the quantity of 6k plus 1. So you distribute the 1/4 to each term. 1/4 times 4k is 4k over 4. 1/4 times 2 is 2 over 4. Negative 1/2 times 6k is negative 6k over 2. Negative 1/2 times 1 is negative 1/2. Now we can simplify this expression. 4 over 4 is just 1, so that's 1k. 2 over 4 reduces down to 1/2. 6 over 2k would be 3k, and then we still have the 1/2 in the back. So that's 1k plus 1/2 minus 3k minus 1/2. The 1/2s will cancel. We have a positive 1/2 and a negative 1/2. They will cancel. Then we have 1k minus 3k, which would be negative 2k for a final answer. Last example, negative 7a minus 4 times the quantity of 3a minus 2 times the quantity of a plus 6 minus 4. So once again, we have grouping symbols embedded inside of another set of grouping symbols. So you work your way inside out. Start with your innermost first. I cannot combine a plus 6, so I will just distribute the negative 2 into the parentheses. So that'll be a negative 2a minus 12. Still inside of my brackets, I can simplify more. 3a minus 2a would be just 1a. So now I have negative 7a minus 4 times the quantity of a minus 12 minus 4. Distribute the negative 4 into the brackets, so the brackets can be completely removed. So that'll be a negative 4a plus 48. Negative 4 times negative 12 is plus 48. Now combine my like terms. I have negative 7a, negative 4a plus 48 minus 4. Negative 7a minus 4a is negative 11a. 48 minus 4 is plus 44. Leave me the final expression, 11a plus 44. Let me know if you have any questions.